Hello and welcome to today's session. My name is Matt Bichelle, Senior Director of Product and Solutions Marketing at Aerospike. I'm joined today by Aravind Sriram and Richard Lee of Adobe. Adobe's been a long-time customer of Aerospike's, and they currently run their experience platform on Aerospike. Today's session is about using Aerospike as a real-time system of record for the Experience Cloud on Azure. And so today, Sriram will take us through benchmarking some of the design choices, talking about data migration, and obviously some lessons learned. Afterwards, we'll pull Richard in and we'll conduct a Q&A session. So that sounds good. I'll hand it over to Aravind. Aravind, take it away.
Thanks for having us here, Matt. We are very excited to be here and presenting. So before we begin, I want to spend a second talking about the Adobe Experience Cloud and what it is. The Adobe Experience Cloud is the industry's most comprehensive solution for analytics, advertising, marketing, and commerce. It allows you to deliver exceptional experiences from creation all the way through monetization and acquisition through renewal. Experience Cloud has played a pivotal role in transforming industry after industry, whether it's financial services reimagining digital customer journeys, or media companies reshaping content monetization, or the world's largest hotel chains delivering personalized hospitality. Adobe Experience Cloud has become the experience fabric for the digital world. So Adobe Experience Platform is what powers the Adobe Experience Cloud. And my team is powering one of the key services in Adobe Experience Platform. So let's take a look at what the Adobe Experience Platform is. So the Adobe Experience Platform provides an open, intelligent, real-time platform that accelerates time to value. All the data that's captured in the Adobe Experience Cloud products will be centralized and standardized in platform in a simple way, something that was not possible before. But in Experience Platform, it's not only for Adobe products, you can configure API connectors to stream or batch data into the platform from any system. And the next aspect of the platform is the real-time customer profile. With high volume, high velocity data coming in from multiple sources, Experience Platform creates dynamic real-time customer profiles. Imagine how better you will understand your consumer by stitching CRM data with behavioral data from Adobe Analytics, or transactional data with attribute data, all in milliseconds, while also taking into account privacy constraints. And there is also additional services on top of the real-time customer profiles. We are able to segment, govern, and look up the real-time profiles. We also enrich the understanding of that customer with intelligence capabilities, while ensuring that the governance is in place. There are two major capabilities. One is a petabyte scale serverless query service, on top of which all this stitched cross-channel data that you're pulling in, you can now start to query against it using SQL, or connect your favorite BI tool and start to derive more insights. The second aspect of it is data science, where data scientists can access this data without pulling it out of the cloud, which creates more latency and cost. And they can start building their own algorithms and run their own IP against this data. And once this enriched real-time customer profiles is available, you can apply multiple decisioning and orchestration, and you can activate them across any channel. So it's an open platform you can access from anywhere on the global distributed edge where experiences are happening, that allows you to get millisecond level access to data and trigger contextual experiences. So the portion that I want to focus more is the real-time customer profile, and specifically the identity resolution. So my talk here is focused on some projects that fall under the identity resolution umbrella and the migration from the Microsoft Managed NoSQL solution to Aerospike. So what is a real-time customer profile? So this is a view of the platform UI that shows the one real-time customer profile. So we have data coming in from customer inputs. This could be from web forms. There's also data coming in from other CRM sources. This could be from MySQL databases that's hosted by the customer. And what this view gives you is a combined 360 view of the customer across all of their touch points. So this data is actually collected under different IDs. So in the IDs mentioned in the red box, each one of them is a separate silo that has some information about the customer. By bringing in all this data together in a single view, we're able to capture a 360-degree view of the customer. And this linking is enabled by identity resolution services. We will spend more time talking about how we link these IDs and the services that power it. So to link these IDs, you need something that's called as an identity graph. So an identity graph, very simply put, is a graph of all identifiers relating to a single person. So as a consumer interacts with a brand and they start to do logins and interactions through a variety of devices, you start to build a picture of the consumer, their identifiers, and their device identifiers. An identity graph, simply put, is all of their personal identifiers and device identifiers linked based on any kind of relationships that were observed. Each person level graph is also associated with a graph ID. It's used internally for storage purposes. So this identity graph is what is being used to power this 360-degree view of the customer. Essentially, the graph tells the system which IDs to link together in order to form the 360-degree view. So in Adobe Experience Platform, we are now leveraging Aerospike for key advertising and identity resolution services. It's being used as a system of record for roughly 100 billion keys. This migration has helped increase our overall throughput by 7x and also reduce our cost by 3x. There are two services that were migrated to Aerospike. I'll briefly cover the requirements for both these services. The first service is called the Graph History Service. This service maintains a time-versioned association between device identifiers and the graph IDs that we just discussed. These associations are stored and served to internal services, and they power experiences like customer journey. There are about 40 billion identifiers, and on average, there are 300 bytes. And we are looking at read throughput requirements of about 275,000 reads every second and about 52,000 writes every second. And the peak, those are the average values, and the peak is twice the average. From an SLA perspective, for GET POST request, we expect a P95 of less than 25 milliseconds. And we have a batch request where the customer can provide 1,000 keys in a single request. The expectation for that response is 500 milliseconds, the P95. The other service is similar in nature, but it serves a different purpose. So it stores partner mappings. A partner mapping is a one-to-one association between identifiers across advertising partners like Adobe, Google, or AppNexus. So simply put, it's a table, and there is a column for each partner, and each row represents the various identifiers stored by those partners for the same device. So we have about 45 billion of these identifiers in our database, and the average size when protobuf serialized is 250 bytes. And in terms of the requirements, they are similar. So we are looking at 185,000 reads per second, 40,000 writes per second, and the same SLAs around latencies. So these are the two services that we are looking to migrate. And the goal for our migration is we want to reduce cost, and we want to improve the throughput and latency, and we want to maintain feature parity with the existing system. So in order to answer the reduced cost part, we need to figure out what the performance is going to be given a set number of resources. So the first exercise is a benchmarking exercise. So we spend quite a bit of time benchmarking Aerospike on Azure public cloud. And I'll spend some time talking about what we did there. So first starting point is you want to identify your application's requirement. Does it require a NoSQL database with single key transaction support? Does it fit this criteria? How many records are you looking to store? What is the average record size? TTLs for the record, what kind of QPS for each of the operations are we expecting? What latencies are we expecting? What backup and restore times are acceptable? If there is a node failure, what is an acceptable recovery time? So these are some requirements to tease out upfront and have them ready. And then you have a selection to make in terms of what type of VM and disk you'd like to use. On Azure, you have the managed disk, and there are 3 flavors of them, the standard, premium, and ultra. And there is a trade-off in terms of performance and cost. The standard being low performance and low cost, and the premium being high performance and medium cost. And the ultra, you get very high performance, but it's a higher cost. Then you have ephemeral and NVMe disk. These offer extreme performance, but the data is lost during certain types of post-maintenance activities. They're only available on L series VMs, and the capacity is fixed, meaning we cannot attach a flexible number of NVMe disks to a VM. It's whatever is provisioned with the VM. And then you have to select an Aerospike deployment mode, and there are a couple of these flavors. You can do index and data in memory. You can do the index in memory and have the data stored on managed SSDs, or the data being stored on NVMe disk, or a combination of both the managed and NVMe disk in what is referred to as the shadow mode. It's also possible to store the index in NVMe or PMEM and the data on disk. So you would have to make a choice on which is the most appropriate for your application to benchmark. And once you have made those decisions, we would recommend that you write your benchmarks in some kind of an automation framework like Terraform or Ansible. So you're able to programmatically spin up resources to provision the database nodes and the load generators and programmatically run the benchmarks. Either the benchmarks that's packaged with the Aerospike binaries, the AS benchmark tool, or you could run the YCSB vanilla benchmark driver, and you can start getting some benchmark numbers. We have here provided a link to a repo with the scripts that we use to provision and run the benchmarks. So if you have interest in running Aerospike benchmarks in Azure and want to get started quickly, feel free to reuse this repo. So our benchmarking setup looks something like this. We're looking at 6 billion 2 kilobyte records, putting us at 12 terabytes of raw storage. The cluster has 5 L48 VMs. Each node has 48 cores and 384 gigs of memory and 6 1.9 terabyte NVMe disks. And we also provision 2 terabyte P40 premium disks for each of the NVMe disks. This is because we run Aerospike in shadow mode and we need a combination of NVMe and the managed disk to support that. We use a replication factor of 2 and a write block size of 1 megabyte. Our load gen cluster is comprised of L16 machines, and we have a variable number of them depending on how much load we want to put. And so here are the results of the overall benchmarking exercise. So I want to call attention to the read numbers. So there are 3 series. The series in gray is when you used only managed disk. The series in orange is when you use only the NVMe disk, and the series in blue represents the shadow mode, which is a combination. And if you look at the read performance when using only managed disk, it is quite poor. We're looking for read performance in the millions of requests per second. And here we are at between 100,000 and 200,000 requests per second. And so it's not quite acceptable level of performance for us. But using only the NVMe mode or the shadow mode, we see really high read performance for single reads between 1.5 and 1.7 million reads per second, which is excellent. And when we do it in batches of 10,000 in this case, we're able to achieve much higher read performance. So, and the write performance is, as said, it's at an acceptable level for our application. So that works out quite well. Shadow mode also has excellent performance, but there are some trade-offs in terms of data durability. Sorry, I meant to say NVMe mode has slightly better performance, but there are some trade-offs in terms of data durability, and we will discuss some of those aspects in the coming slides. What are some design choices that we made? Okay, the first one, we just talked about it, managed disk versus NVMe versus shadow. There is a trade-off when using each of these modes. When you use a managed premium SSD, you get low cost, and low performance as noted in the benchmarks. But there is durability, meaning if you lose the nodes, the data is durably persisted on disk in LRS, so it's replicated twice within the same region. So you have good durability there. NVMEs, the cost is moderate, performance is extremely high, but there is no durability, meaning the VMs, if they are going through a clean restart, the data will persist. But if the VM is reallocated to a different host for host maintenance, then you will lose the data. So unless you need to have enough replicas available, and if you lose all the replicas because of some outage, then you will have data loss. So that is something to keep in mind. The shadow mode provides the best trade-offs because it combines the high performance of the NVMe with the durability offered by the managed SSD. And so for us, it was the better choice. Bin packing. So this is another interesting design choice. So imagine that you have an app with 100 billion keys, each of 250 bytes of value to store with 2 replication factor. So your index size is about 12.8 terabytes, since each record takes 64 bytes in memory, and your data size is 50 terabytes. So if you assume L8 VMs, which have the 64 gigs of RAM and 1.9 terabytes of NVMe storage, you're looking at 200 VMs to meet the index requirements and 26 VMs to meet the storage requirements. And you obviously need some minimum number of VMs to meet the throughput requirement, but you need to do some benchmarking to figure it out. So the question is, how can we reduce the index requirement? Because that's a lot of VMs. So one idea is you can do bin packing. So pack n records into one packed records at an application level, similar to a hash map kind of a data organization. So if you store 8 250 byte records into one packed record, you appropriately, you have a hash function to rekey the documents. Your index requirements will drop from 200 to 25 VMs, and that's going to represent a huge savings in terms of cost. Another option is you can use the Aerospike map data structure that lets you, you can do a similar rekeying, a hash function to rekey from the record IDs to a hash ID, and then use the hash ID to store a map of the key value pairs. So that is certainly another approach to reduce the index requirement. This is typically for systems or situations where you have a large number of small records, and then you're looking to reduce the size of the index. On serialization and compression, these are very key to reducing the record size, because if you can reduce the storage requirement, that translates to lower cost, and that also translates to increased performance. How can we do that? Use better serialization, use binary formats like protobuf over JSON, use compression. In our data, we noticed compression was enabling 40 to 50% savings in the overall storage footprint. So definitely compression is something to pay close attention to. Use a generic key value store interface. So having a generic abstraction will help your app be decoupled from any specific database implementation. It's easier to move across key value stores, and then it simplifies testing. Doing an online migration. So when we did the migration of data from our live DB to Aerospike, we did it in an online manner. What we mean by that is data is ingested into both databases simultaneously. And in parallel, we trigger a migration from the old database to the new database. This does require that you have a merge function that merges records correctly, and also you require idempotent operations. The benefit is there's no downtime, there's no SLA impact to downstream clients, either for the query path or the ingestion path, and the rollback procedure is quite simple. In terms of operations, on the backup and restore, we noticed sometimes it's better to do full backups than doing too many incrementals, because there is a cost when you have to do the restores or many incrementals. Also, it's very helpful to retain the input events for some amount of time, so that you can have a flexible data reprocessing path. So you can go back to a previous backup and then use reprocessing to make sure that you don't have any data loss. We also store backups in Azure GRS blob storage. So that way, in case of a disaster, our data is replicated in globally across 3 different regions. Some lessons learned in this whole process on the Aerospike side, we noticed that shadow mode is an excellent option. It lets you take advantage of the excellent NVMe read performance and combine that with the durability offered by managed tests. So definitely shadow mode is something to consider in your deployment as well. The compression feature was a huge win for us. We were able to save up to 50% on storage footprint, and it was great for the cost saving story. And we have this situation where it's a large number, we're talking 100 billion plus number of items, and each item is 200 to 300 bytes. So it's very helpful to do bin packing or use alternative data structures to keep the index size small. And the online migration, that was a big win for us because there was no service downtime or SLA impact. Things just went very smoothly. On the operations front, we noticed too many incremental backups resulted in a long restore time, and our preference is to not to have too many incremental backups. We ran into an issue with time drift and then later discovered it was because NTP ports are UDP ports and they needed to be explicitly open. So to remember to open the UDP ports required for NTP. On the Azure virtual machine scale sets, there were a lot of frequent unplanned maintenance, and we had a lot of cold starts. So that is something to watch out if you're operating in Azure using VMSs. We also noticed you can partition the disk, and using 4 disk partitions improved backup times significantly. Also, we recommend going with smaller VMs. This is mainly to reduce the impact of migration during any kind of no restarts or failure scenarios. Also, the backup restore scripts are great, but also have your reprocessing pipeline ready for any historical backfills. A combination of backup restore with historical backfills basically allows you to recover to any point in time in case of a corrupt data or bad code push. That's all the content I had for you. I hope you found some of this helpful in your situation. And thank you so much for having us. Over to you, Matt.
All right. Well, thank you, Aravind, for taking us through the presentation. And thank you, Richard, for joining us for Q&A. So with that, I thought I might ask a little bit of a general question either of you could answer. And just, you mentioned that the size of the data in the benchmark was 12 terabytes, if I remember correctly. Was that data live data, or was it generated from YCSB? I wasn't quite sure on that. Either of you can answer that question for us.
Sure, I can take that one, Matt. So that data was generated using the ACE benchmark tool. I think the format of the data is very similar to what YCSB does.
Okay. Okay. Yeah. So in the presentation, Richard, I heard the mention of batch requests, which I don't typically associate with Aerospike. We usually think of ourselves as a real-time data platform. But can you elaborate in the use case of Adobe Experience Platform?
Richard, do you want to take that one?
Yeah, sure. Sorry, my connection was not good. Sure, Matt. So yeah, the system requirement to perform for the request is somewhere between 100K to 1 million. And our SLA P95 is about 300 microsecond. So by batching the lookup operations, we're able to increase the overall throughput for the system at the expense of the increased latency. So now, in that way, just like grouping the lookup operations, we're able to meet these SLAs by the batch size of 1,000.
Yeah, if I could just add to what Richard is saying, right? Like if you have a system that's operating in the millions of queries per second, each query is going to put a certain amount of overhead in your network and so on and so forth. So batching is a good optimization in that sense. Overall, your system efficiency is going to improve, and latency is the only other factor that's going to be affected. But in our case, we are able to stay within our SLA, so it wasn't a factor.
Or if you're, I think you may mention bringing additional sources online, if you're bringing a new source online, data feed, maybe to a system of record. Okay. See, you guys, Aravind, you mentioned listing multiple options for VMs with different disk choices, based on performance. Yeah, you already stated that your SLA had a P95 performance threshold to meet. So I got the sense it'd be a little bit risk-seeking if you had picked the wrong VM class. Could you maybe talk about, talk about the options there and still meeting that P95 need?
Right. I guess our P95 was 25 milliseconds, so there is some amount of buffer there. So we could have gone with managed disk or NVMEs, and you would still be able to stay within that latency SLA. But there is also a throughput angle to this, right? So I don't believe from a latency perspective that having 25 millisecond latency SLA forced us to go down a particular path in terms of disk choice. I think the 25 millisecond can be achieved with the various options that were presented. But it's more on the throughput side of things, like, would you be able to achieve a 1 million QPS throughput using managed disk alone or some other option? So that's the forcing function for us. And that's why we went down the path of the shadow mode, which allows us to provide excellent read performance by leveraging the NVMe disk. The write performance is still limited by your disk choice, but typically, or in our application, we had much lower write requirements than the read requirements. So that's why we went with the shadow mode, right? So we can take advantage of the excellent read performance, and then the write performance was sufficient when we went with the P30, P40 premium SSDs.
Okay. Yeah. So it's good to hear that there's options, with Aerospike to get to certain performance as performance thresholds as needed. You listed 85, I think it was 85 billion keys for identities. So maybe Richard, you want to tell us about, the plans for growth? Is this current or is this anticipated? How might you and Aravind see Aerospike working with this amount of size and any growth plans?
Yeah, so we have 85 billion keys right now for various applications added together. And we anticipate 50% growth in the next 2 years. That'll bring us somewhere around like 100 to 130 billion records. So that's why we're leaving some buffer room when we're designing the data models. Using some compression and some of the bit masking method to leave some buffer room right there.
And so given that amount of growth, does that mean that your team needs to grow by the same amount, or has that not been discussed internally?
Well, yeah, so like onboarding different customers and existing customers, the traffic will also increase, and possibly the scale of the application will also growing bigger.
Okay. Aravind, you mentioned Binpacking as a way to save on storage for indexes. Was that an obvious decision, or how did you arrive at that?
Well, I guess once we saw the data, that was an obvious decision for us. Simply because our application is unique in the sense we are storing tens of billions of records. Each of those records are really small in size, so 250 bytes. Unfortunately, we don't have access to PMEM on Azure. And so the whole index on PMEM, that option is not available for us. And so we had to go with the more traditional deployment option. So once we calculated the storage requirement and the index requirement was like 10x of storage. And sure, you could go with such a big deployment and it would be extremely performant, but it's going to be expensive as well. And we simply didn't need such a high performance deployment. And so for us, this was kind of an obvious choice. We needed some way to reduce the index size without taking a big performance hit. And Binpacking allows you to do that.
Okay. You guys mentioned that you're creating identity graphs with Aerospike, which makes a lot of sense given what Adobe Experience Platform does. But I wasn't really clear if you were using Aerospike itself as a graph database. Could you maybe Richard, you want to take us through what that means?
Yeah, sure. So in that regards, we're still using Aerospike as a traditional NoSQL database to drive our identity graph related use cases. So which means there are still transaction focused use cases, including some online transactions, accountings, and so on. So we're not just focused on the relationship heavy use cases, which are kind of like a recommendation for different identity graph or some complicated queries for the like maybe graph traversal, things like that.
So in addition, you said you're able to use Aerospike as a transactional database or transactional workloads as well.
Transaction focused, but that's yeah. So we are not, yeah. We're still largely use it as a NoSQL database, which means we're just looking for some eventual consistency instead of like a like a highly transactional focused. That's
okay. Yeah, I mean, I might purport that Aerospike with our strong consistency could do that. It may not be required for Experience Platform, so totally understandable. If that makes sense. Okay, I think we are unfortunately at time, so I want to thank both of you, Richard and Aravind, for taking the time to create and walk through and then answer some questions with us. So hopefully people want to reach out to you on the platform. I assume that might be okay.
Sure.
Okay, and so thanks again each, and thank you everyone for listening in.
Well, thanks for having us, Matt. We really appreciate being here and sharing what we learned.
Yeah, thanks, Matt.